Okay, so finding the dihedral angle. Line of intersection. Trying to find the dihedral angle between A and B. So as always, I want to look 90 degrees to the line of intersection before I do anything else. So I'm setting up my XY parallel to the line of intersection. Okay, so I'm on at the moment, for me it's my X2, Y2. I'm going to project out the points perpendicular to the line of intersection. Okay, I know that this point, I'm going to call it point 1, has a height of 0. This is also point 1 up here. So point 1 is on the ground. Once again, this X2, Y2 represents an edge view of the horizontal plane because I'm taking an elevation. Plan, elevation, plan, elevation, plan, elevation. Each of these XYs, X1, Y1, X2, Y2 represent an edge view of the horizontal plane. Okay, so my height, that point, I'm calling point 2. Now from the previous part of the question, point 2 has a height of h, which was the same height out here. Okay, so my height of h, 7. I'm going to mark that height of h up here. Just going to mark it in as red, the same as the other ones, just so maybe it makes a little bit more sense. So that there is a height of h. I know that height h joins back to here because that is my point 2. So this is the true length of the line of intersection. Height of 0, height of h. Give me 0.2, 1, 0.2, 1. Okay? So even apart from anything else at the moment, I know that the next thing I'm going to do is look perpendicular to the line of intersection. Sorry, I'm going to look along the line of intersection. When I look along the line of intersection, I'm going to be able to project a point view of the line of intersection. So even if I wanted at the moment, I could project that. Set up my XY at 90 degrees to it. Just to start me off. So I'm going to keep this close, hopefully this will actually fit in. So there's my XY. Projecting along this, I'm in my current view, last view, second last view, so my distances will be back here. Okay, I could shorten this up by putting in a datum XY back here someplace. I won't for the moment, but again, just remembering perpendicular. Perpendicular. I am now on an X3, Y3. Okay, so next thing I'm going to do, rather than dealing with this full surface of A, let's see if we can bring this brightness down a little bit, but not that much. Okay, I think that's a little bit better. So I've got my surface A and surface B, which at the moment are quite large surfaces. So what I'm going to do with them is just break them up into two smaller surfaces. I'm going to go from 2 down as far as the ground. And I'm going to go from 2, I could go down as far as the ground there. Let's do that. Okay, so I've now created two smaller surfaces. I'm going to call that point 3, I'm going to call that point 4. Remember, point 4 is on the ground, which means point 4 is actually back behind 1. Point 2 we have, point 1 is the ground, point 3, if we want to put it in the front elevation, is also on the ground, which is at that location. 0.3 joins up to 2, and this all this is a triangular surface on the existing surface. Okay, so I have my two triangles. Again, I'm going to project these to my auxiliary view. This properly. Sorry if I even actually got it right. There we go. So I'm projecting down 0.4 and I'm projecting down 0.3. Okay. Said 4 is in the ground, 3 is in the ground. So 0.4 is right there. 0.3 is right there. 3 joins to 2, 4 joins to 2. So 3 is going to join to 2, 4 is going to join to 2. The only issue with actually drawing the triangle so small is that these points are very close together. If I went from 2 as far as this corner, say, or from 2 as far as this corner, these points will be a little bit further apart. It's probably a little bit more accurate, but it's still going to work out as long as you have the method correct. You're okay. So that's going as far as 2, and that's going as far as 2. So that's the only issue with this at the minute, is these two lines are very close together. Okay. I'll try changing that brightness again a little bit. But other than that, here are my two triangles. I'm projecting out this way. My distances again from the current view, last view, second last view, from the x2, y2 back to here. At this stage, I would definitely stick in a datum xy just to save space. So my data must be parallel to this because I'm taking distances from here back. So all I'm doing is reducing all of those distances by the same amount. So let's go and put in a datum xy. Right there. Okay, so at least now my distances are shorter back to 3, 2, 1, and 4. Those distances I'm going to step off down here in this view. Remember again, everything must project perpendicular to the xy, or the x3, y3 in this case. They're going out that way. Just be careful because these three lines are so close together, it's easy enough to, it will be easy enough to actually put the measurements in the wrong lines. Sorry, just trying to adjust this brightness again. So distances back, again, 1 and 2 are going to be the same distance, which for me is 21. So my line 1, 2, they're always going to be the same distance because that needs to end up at the same point. So the line of intersection, which is the true length line here, look along the true length line, and they're going to be at the same location. Distance out to 4 is 35, and I'm making sure I'm going off the right line. And that joins back to 1 and 2. And my distance back to 3, which for me is 5. Mark that out there. And that joins to that. Now again, you'll notice the dihedral angle here, the actual two edge views are quite small because I made my triangles up here quite small. So if I wanted, there's no problem just extending those lines to just throw the protractor on it to actually measure the angle. Okay, it's not going to affect the angle. And there's your dihedral angle. Okay, so again, 0.3 was my closest point. There it was there. 0.4 a bit further away. That's 0.4. Okay, and the dihedral angle is contained in that space. At the very least, you should be taking a compass and putting it on the point view and marking in an arc. Okay, then trying to make it a little bit heavier than it needs to be just so that you can actually see it. but there's your dihedral angle. That angle shouldn't change. If I had made my triangle go from point 2 down as far as the corner here, from point 2 down as far as that corner, it should be pretty much the same. It might change very slightly because I said it would be a little bit more accurate if the triangles were a little bit bigger and further, these points were further apart. Okay, but other than that, that should do the trick. Yeah, hopefully this helps somebody. Apologies for the change in lighting, but this phone just doesn't seem to want to actually do the selective focus and stay on the one adjustment the whole time. Anyway, does the trick hopefully.